So the first part's done. We've calculated what the current is. The last part that we need to do is calculate what the resistance would be, or the impedance. So redraw your circuit, short your voltage source, and the current is going all the way through the capacitor, and oops, it splits. So the order of the impedances is a little bit switched from our first equation. Sub in our numbers again. Again, I'm a bit repeating myself, but you solve it using Pythagoras' theorem, 68.65 ohms, and the angle using tan, which is minus 46.8 degrees. We can now put in the angular form where we had the rectangular form. We can multiply the magnitudes, divide them, and add and subtract the angles accordingly. We need to add two polar forms. Let's switch them to rectangular. Something that has minus 90 degrees means that it doesn't have a coordinate in the x direction, so we only have the y, i.e. y is just minus 100 j ohms. Pascal sign and cos to find what the x and y trajectory, or the real and complex form. That would be 24.9 and minus 23.27 j. Sub it in, add and subtract like with like. 24.9 ohms remains the same, minus 100 j, and minus 23.27. Our Norton impedance becomes 24.9 ohms and minus 123.27 j. We can redraw the circuit like this, where Norton's current and the impedance as a resistor and a capacitor. Happy circuiting.